So next set of topics, I would like to briefly jump to our outline. There's this handout for user-defined data types. Right, so there's a presentation. It's rather a short presentation, not very big presentation, just a few topics which cover the structure, which and also covers ways to initialize it. So I'm not going to follow this presentation precisely because at some point we may come back to it, but at this point I will just run some code examples similar to what we already have done. So you already know that there are fundamental data types. We call them basic or fundamental, or sometimes rudimentary, or simple data types, because they're directly supported by the computer architecture, and they are such as an int, as an index, right? A character, which is usually 1 byte in size. Character, we can initialize it with character literal. Then we of course considered using like integer pointer, where we took address of another variable, and we would say that pointer data type, which is an int with an asterisk, is yet another data type. It's very similar to integer, but instead of storing some user data, it stores addresses, right? So that's yet another data type that we use. But there's still fundamental data types, and asterisk here simply is just a type modifier that makes it a pointer to integer as opposed to plain integer. Similarly, we could say character pointer, right, and say PCH equals address of CH, and we could do something like that. But more often we could have done something like this, const pointer, like greeting, right, and point this to a sequence of characters like that, and so forth. So to this point, we stayed in this realm of basic data types, which are usually quite recognizable in the code because they have these highlighted, usually we use keywords such as int, char, and so forth, because they're directly supported by the language. They're all keywords in the language, and obviously highlighted in the source editor that you normally use. At the same time, we said that as well as having a single variable, you can have an array. Int integer, I don't know, my array for the lack of better name, and allocate 100 integers and initialize them all with a 0, right? So we've talked about this last week. So this is yet another data type that you can have, just as you can have a single integer such as index. You can also have a block of integers, like 100 of them. And today we talked about dynamic allocation of arrays. But an array, let me just reduce this number to say like 4 integers and try initialize them with 10, 20, 30, and 40. We usually say that an array, like my array in this example, is an aggregate data type. Why? Well, because it aggregates, kind of like puts together a sequence of elements. It's a very primitive facility, we already know. It gets allocated just like any other variable, on the stack in my case, and my stack frame that's given to main will now have these 4 integers, and they all will be populated with these values. But a limitation of an array is such that it can only aggregate the data of the same type, right? Of the same type. You cannot have an array of doubles and floats and integers at the same time. But once in a while, you may need actually something that could aggregate the values of different types, right? So if I'm thinking about my computer screen right now, right, I may have to consider something like a pixel, right? A pixel most likely has something like coordinates such as, for instance, integer x, right, and integer y, and then it has a color, right? So we have colors which composed of individual pieces, and I can say that maybe I can have a character of byte specifying, for instance, red, green, blue, and also a character alpha component, which basically allows us to blend colors. If it's, say, set to 0, it would allow us to completely blend any colors we want, and if this thing is set to 1, it will not allow any mixture at all. Like, it would make the latest color of some specification would be the color that the pixel should use. So no mixing. Right? So, but this is how the colors are usually specified. So they're red, green, and blue, and so forth. But notice that I want to specify pixel that has the coordinates, the components that correspond to the coordinates of this pixel, and also components that correspond to the color. Right? At some point, I may decide to make this a float point variable. For instance, right, I could do that and use even more different data types, and yet keep an alpha component in a range of like from 0 to 255 in terms of the alpha component for blending my colors, and I may even saying that I want an unsigned character for that. Unsigned character would not allow to store negative numbers, only positive numbers. The important thing here, and I don't want to kind of confuse you with that, but it's quite the possibility. Well, anyway, notice that these are all little components of a pixel on my screen. How can I make this a real concept? Like, for instance, if I want to have a pixel and work with pixel, I always need all of its components. How can I manage that? Well, the answer is simple. You simply say struct number 1, and number 2, you just add semicolon at the end, right? And I would normally, just as in my Java programs, if you're following my Java class, I would mark the ending of my structure like this to be marked by its name, struct pixel.